Hello people from the internet, Andre here again, and once again we are going to talk about the samplers and schedulers. We are really trying to explore and understand these things, and I have something really cool today. This video probably is going to take longer, but why not? Let's go. Do you guys remember this that we've made on a video before? It's our ConfUI workflow for testing the samplers and the schedulers. And look at this. I want to present you the plus version, and it's here. You can see it's awesome by the quantity of lines that you can see, and take a look. This thing is huge. It's not hard to do. I just duplicated the things and I teach you on how to do it, but that's what we are going to be using today for do our explorations. I've made a little bit some changes. I've put some things external to the case sampler, so we can define here and change in all the case samplers. So the seed, I think the seed was already out, and now we have the steps right here, so we can define the steps here, and we have the CFG here, so we don't need to change in all the case samplers. I only left the sampler and the scheduler and the denoise that we are not going to change, but the sampler and the scheduler on the case sampler node. So what we are going to do today, we're going to do some tests on the samplers and the schedulers, and we are going to try to understand this with the help with some help of AI. And to start this, we are going to use Stable Diffusion 1.5. We are going to do at first this complex prompt, which is cat, the negative prompt text, ugly, deformed, and our size, and seed number 1, 20 steps, and CFG 5. And let's run this huge thing. It does not start running right here. It's kind of random. And so what we have here, we have like this is a group. So we are going to test here all the Euler sampler with different schedulers, and this is going to happen with all the other groups. And we are testing the Euler. We are testing Heun. We are testing DDM uniform. Oh no, Euler. I read it wrong. Sorry. Euler, Heun. DPM2 because I couldn't find just a DPM. LCM and DDEM and UniPC. That's all that we are testing right now. So while it loads the things and starts creating, let's study a little bit together. So what I asked here to Claude to explain us. So my prompt was, I want to understand in a simple way what a sampler is and what a scheduler is in Stable Diffusion. Tell me about the samplers: Euler, Heun, DPM, LCM, DDEM, UNPC. We have that on our workflow, and the schedulers that we are using also on that workflow that's running right here. It already started running. Yeah, ugly cats all around. And we are testing, we want to know about the schedulers: normal, Keras, exponential, SGM uniform, simple, DDM uniform. So let's read these together. So in Stable Diffusion, samplers and schedulers are important components that influence the image generation process. Let's break them down. samplers. Euler, a simple and fast method that uses Euler's method for numerical integration. It's less accurate compared to other samples, but can produce decent results, really good results. Euler is a good sampler. Heun, an improved version of Euler sampler that uses Heun's method for numerical integration. It provides a balance between speed and accuracy. DPM, which is Denoising Diffusion Probabilistic Models. You didn't know that, and I also didn't. A sampler that uses a probabilistic approach to generate images by iteratively denoising a random noise input. It can produce high quality results, but may be slower than other samplers. DPM is also a good sampler. I use a lot of Euler and DPM, and when it says slower here, I think that means it needs more steps to get to good results. LCM, likelihood-based sampling, a sampler that uses likelihood-based methods to generate images. It aims to maximize the likelihood of the generated image matching the conditioning information. This is an interesting sampler, and we are going to explore it. DDEM, Denoising Diffusion Implicit Models, a sampler that combines the benefits of both diffusion models and implicit models. It allows for faster sampling while maintaining good image quality. And UNPC, Unified Predictor Corrector, a sampler that uses a predictor corrector approach to generate images. It combines multiple sampling steps to improve the quality and stability of the generated images. So these are the samplers, and I think the samplers are the most important part of your choice, and the schedulers, they can help. They do help, but like the sampler, it's as far as I understand in my experience, is a decision that will influence more the quality of your image than the schedulers. But let's take a look on the schedulers too. So normal, the default scheduler that uses a fixed number of sampling steps. It provides a balance between image quality and normal generation speed. Normal is a good scheduler. The name is boring, but normal is a good scheduler. Keras, this one is pretty famous. You're going to see a lot of people using Keras. And it's creative, like it gets you different results. A scheduler proposed by Tero Keras et al. That adapts the number of sampling steps based on the complexity of the image. It can produce high quality results while reducing computation time for simpler images. Exponential, a scheduler that increases the number of sampling steps exponentially over time. It allows for more refinement in the later stages of image generation. Also a good scheduler. SGM uniform, stochastic gradient method with uniform noise. I don't know what stochastic is. A scheduler that uses stochastic gradient methods with uniform noise to guide the image generation process. It can help in exploring diverse image variations. Okay. Simple, a basic scheduler that uses a fixed number of steps and does not adapt based on image complexity. It's faster, but may sacrifice some image quality. And the last one, scheduler, DDEM uniform. A scheduler is specifically designed for DDEM sampler. It uses uniform noise to condition the generation process, and it can produce a diverse and coherent images. So there's a lot of text. And what do you need to understand? You do need to understand that you need to test it all and to see for yourself what's happening, but and the results. But you do need to understand that some samplers, they will work with less steps, and some samplers will need more steps to work, and some samplers, they are capable of giving you like more image quality in the end. So that's kind of it. So but that's a lot of text, and we can experiment with the things, and this take 10 minutes. You're a hero if you're here, but the fun is just about to start. Let's go. So let's take a look on our first experiment. So here we have the cat using Euler. So it seems like the same cat, but maybe this DDEM uniform gave the cat better eyes. Okay. Here also this kind of the same cat, different eyes on DDEM uniform, but I do like more the Euler scheduler here. The image result seems better than Euler. Heun better than Euler. Then we have DPM2. Also pretty similar to Heun, I think. We have LCM. What a disaster right now. Like using Stable Diffusion 1.5 base. Not a good choice. But can be a good choice, and we are going to see this, but not right now. DDEM also not the better results. Like DPM is giving better results right now, in my opinion. And UNPC and UNPC DDEM uniform seems to me like one of the best results. I don't know, maybe not. But can you see, like, some samplers are kind of giving you the same result, like OIM, DPM, and UNPC, and DDM, you know, kind of the same results. LCM, super strange. Maybe I think that in this batch, UNPC won. But let's try something else. Let's try this same thing, but with dog. And go. Let's see what results we get. And starting here with a strange dog. Something interesting that I've noticed, because I do test this before showing you guys, it's that LCM is giving me the most diverse results when you like change the scheduler. The image is really different. Like these are completely different dogs, and this also. So that's interesting. It's giving a really different result when the results that you get using other samplers and other schedulers are more similar. Let's take a look here. What an ugly dog. And we are also going to start to learn a little bit more about prompting, because a simple prompt like this will not get you great images. But if we are more specific on what we are asking for, we can improve a lot our results. For example, the next prompt that we are going to try, it will be German Shepherd. Let me do this. Translate Google. Not this. Again, translate Google here. That's what I need. Let me write this in Portuguese. Yes, German Shepherd. Thank you, Google Translator. Because here I'm just asking for like a general dog. So it does not have a lot of information. Like it's kind of a blend of dogs. If I ask, like the prompt is still simple if when we ask for a German Shepherd, but it's more specific. It's just one kind of dog. So this alone is going to give us better results. And almost done. Yeah, done. So here we have Euler trying to do two dogs, the one dog with a red tie, I think. Oyum trying to make that a new dog face. LCM again, super different. Keras also managed to do a second dog face here, and maybe a little dog in behind. DDEM2 and UNPC. I don't like any of these results, but maybe like this dog is better, like overall. Let's try the other prompt that I suggested, the German Shepherd. Let's go. German Shepherd, go. And notice that here we are using Stable Diffusion 1.5 to do these tests, but the next test that we're going to do, we're going to use a fine-tuned version, and you're going to see how different the results are with a model that has been fine-tuned. Let's take a look on this German Shepherds. Pretty good. I think I had not played too much before, like with this UNPC. I was always just using Euler and DPM, but I'm liking these results. I feel like I should be exploring this option a little bit more. Let's take a look on the other results. Man, there's a there is some red influence in this seed number 1 in the middle. Like on the other image, it was trying to put a red tie here, and we also have a kind of a red thing happening here, depending on the scheduler. And the other is like there's a huge tongue, and yeah, definitely some heavy influence of the red in the center on the seed number 1. Is it done? See the okay. I think it's almost done. DDEM also made a good work, but wow, look at that tongue, like that's disproportional. DPM, one of the favorite schedulers of everybody. LCM giving us the weird results using 1.5. Okay, let's test with another model. You can download the model you want, test with whatever you want. I'm going just to use this epic photogasm last unicorn. Let's see how it performs. And what's interesting right now is that we are going to start to see good results coming from LCM when we are using the fine-tuned models. And that's I say that it is interesting because to me, I was like, why I am testing the sampler if these results they are so horrible? But I had already made the whole workflow. I was not going just to delete and leave a hole just in the middle of my workflow. But I was surprised when the first results came, and here they come. Like, it does not, like, compare these results with what we are having right now using LCM, and I don't see people using this too. So wow, you're learning cool things here today, right? Like, take a look on this result. That's a cool result, and that's coming from the same seed. And I don't know. It's just amazing to me. And now when we start to see the other samplers working, they also shine. They also have their qualities. But I was really impressed with LCM uh, giving us like really creative outputs that at least they are different from the other samplers, right? UNPC, again, really good. As I said, normal is boring on the name, but does give good results. Like this is consistent. That's a good result over, you know? Also thinking that this SGM uniform is also good. That and you know that's why we are doing this. That's why we are trying and experimenting, because that's the kind of stuff that you're just going to find out if you test. Maybe you're not going to be able to test like all these variables in every creation that you're going to do, but exploring this, you're at least going to be able to like have your own opinion in what sampler, what scheduler and I'm using and why. See again, normal scheduler, really good. Better, even better than the exponential. That should give us better results, I think. And just one more test that I want to do with you guys is that right now I want to test a prompt that's more open to the variety of results that we can get. So maybe we can see the qualities of each sampler and scheduler in a different way. And we're going to test orange juice. And let's go. And study it again on LCM. About the text that I was reading for 10 minutes, I'll just copy and paste that on the here below the video on the description. On the description, you probably already saw it because I just had this idea right now, and you have access to the description since of the beginning of the video, but I just thought on sharing that right now. Almost 23 minutes in. But it's interesting, right? To see I could spend way more time here testing these things. Let's see. Let's judge the things. Here, LCM DDEM uniform. I thought that's the better of this group of best image. Here, I would vote for UNPC exponential. I like this plate more than the others that it was trying to fit in orange below. DDEM, maybe the normal. Yeah, the normal's good, and this one's also good. I like the orange here. It's different from the plate. And how it's doing here. On Euler, let's choose one. Euler and Keras seems more delicious. In Heun,